Okay, here we go. So, eyes up here, eyes up here. So, um, just cause that's how it ended up. So we need to use two really, really important pieces in mathematics right now in order to understand what's going to happen. And we're going to use these inverse operations. And this is really the idea. If you wanted to solve for x squared, you would square root both sides, right? That those are inverse operations. If you wanted to get rid of 2 times x, you would multiply by 1/2 or divide by 2, correct? If you wanted to get rid of a function, you would do a function inverse. Now, I know that that is not as intuitive as the others, but the fact is we've been learning inverse operations this whole year. And in trigonometry, you'll learn even more. Well, these are inverse operations, logarithms and exponentials. So if you have log base 3 of 3 to the x, what happens? Those cancel, leaving you with just x. And if you have this, those cancel, leaving you with just x. And so it may look like voodoo math. It's not, okay? It's very helpful to solving these type of equations. 8 to the x is equal to 162. What is 8 to the 0 power? What's 8 to the 1 power? What's 8 to the 2 power? What is 8 to the 3 power? 512. So x is going to be somewhere between what two numbers? 2 and 3. How do you solve it? Well, that's a good question. I mean, that's challenging to figure that out. But now with logarithms, it's quite easy. We do the same thing to both sides. We take the log base 8. Watch how beautiful this works out. Log base 8 of 8 cancels, leaving you with thank goodness for our lesson yesterday. We learned how to solve or be able to give a numerical expression for log base 8 of 162. What did we do on our calculator? Log of divided by log of 8. We do log of 162 divided by log of 8. You should get 2 point something. All right, so we'll call it 2.45. We'll round to the hundredth. If you want to check your answers and you're using logarithms or exponentials, you should go out to 6 decimal places. But for the sake of just saving time, we're not going to write out to 6 for these problems. We're just going to go out to 2. If you check your answers, you should write out 6. Okay, so now I have to get rid of the e. So I take log base e. What is log base e? Natural log. So we take the natural log of e to the x, and that's equal to the natural log of 2. What happens to the natural log of e to the x? Leaving with just x equals the natural log of 2. You have a natural log button on your calculator. What is the natural log of 2? Excellent. You do C, D, E, and F on your own. When you get the answer, come put it up on the board. You don't have to show your work. Just give us the answer. Make sure we can check it and make sure it's right. Okay, looks good. Who did E? You did E? What is that? Is that a 7? Okay. Like that? Got it. That's all right. No, it takes practice, right? All right, you're going to want to change D and F. I rewrote them. So we have 3 to the x plus 1 equals 2 to the x minus 3, and e to the 2x minus 5 e to the x plus 4 equals 0. Settle. Got it? we'll do the backside as well. Okay, so what we need to do is we need to get rid of the e. And so we'll again take the natural log of both sides. Natural log of e to the 2x minus 3 is equal to the natural log of 7. What happens here? Let's go away. I'm left with the 2x minus the 3 equals natural log of 7. So I convert that to a decimal. What is natural log of 7? 1.95, we'll say. I add the 3. 2x is equal to 4.95. Divided by 2, x is 2.4. So we got kind of your feet wet doing some easier problems. Now we're going to try more challenging problems, okay? So look at letter B. What's my first step? You could distribute the 2 to get an 18, but then you would have to make sure you didn't do 2 times the 12 because that's not the same as 24 to the 7 minus x. So if you do distribute, just be careful to not multiply that out. So what you might want to do instead is divide by the 2 right away. 9 minus 12 to the 7 minus x is equal to negative 934 divided by 2, negative 467. Now what do I do? Subtract 9, so negative 12 to the 7 minus x is equal to negative 476. Divide the negative. Again, the negative is not being taken to the 7 minus x. That would have to have parentheses around it. So that's why you can just divide that negative 1 off. 12 to the 7 minus x is equal to 476. Now what? Log base 12. Take the log base 12 of both sides. You get 7 minus x is equal to, on your calculator, compute the log base 12 of 476. Again, we do that using a change of base formula, which we learned yesterday. 2.48. Subtract 7. Get negative x is equal to what, 4.52. Negative 4.52. And then so x is 4.52. I take the log base 12 of both sides. So I take log base 12, the 12 goes away. Log base 12 of 476. I do log of 476 divided by log of 12, and I get 2.48. You try C on your own. Go. Log base 2. So 1 divided by 2. Log base 2. Both sides. Okay, what'd you come up with a log base 2 of 46? Okay, you've now seen a number of, I would say, kind of easier exponential equations. Let's try some harder ones. What makes D more difficult? So you're at a tough spot here. If you take the log base 3 of both sides, the 3 goes away, but then you got the 2 over there. Might take the log base 2 of both sides. The 2 goes away, but then you still have the 3. You might get real fancy. You take the log base 3 of the left side and log base 2 of the, log base 3 of the left side and log base 2 of the right side, and then you're doing voodoo math because that's totally illegal, right? So I've seen all sorts of interesting mathematics come up when I ask this problem on a test, and the fact is we just got to choose one and go with it. So you want to do log base 3 or log base 2? Okay, we'll do log base 3. What happens to the left side? Everybody see the trick? Yeah, very good. So this part right here is going to come out in front because it doesn't cancel. So we have 2x minus 3. That's that quantity times log base 3 of 2. I can now take the log base 3 of 2 and convert it to a decimal and then distribute it and solve. So x plus 1 is equal to 2x minus 3 times, what is the log base 3 of 2? 0.63. I distribute. X plus 1 is equal to 1.26x minus 1.89. So our gathered terms on the same side, negative 0.26x, negative 2.89. X is tricky, huh? Try E on your own. See if you do E. Okay, please notice in your solution set that this ends up being a plus or a minus 2.67. So it is an x squared. Okay. All right, so let's move on to the next problem. A little tricky here. E to the 2x minus 5, e to the x plus 4. Different than the others, right? Everybody see something that works out quite nicely with this problem. It factors. Yeah, if you looked at a similar problem, say x squared minus 5x plus 4 equals 0, you would factor that, wouldn't you? Because x times x is x squared. Well, what do you multiply by itself to get e to the 2x? E to the x times e to the x is e to the 2x. Because when we multiply two bases, or two things that have a common base, you add the exponent. And what's x plus x? 2x. So therefore, this will factor e to the x, e to the x. Where two numbers are multiplied to 4, they add a negative 5. Yep, negative 1, negative 4. So we set them both equal to 0. Because we use our zero product property. So e to the x is equal to 1, and e to the x is equal to 4. How do I get rid of the e's? Natural log of both sides. And we get x is equal to, what is the natural log of 1? So, natural log of 4. Done and done. What do you think of that? Let's switch it up. We were just solving exponentials. Now let's solve logarithmic equations. I want to solve for the x. So I want to get rid of the log base 5. And you remember from where we first started out that I put, no, not that. I put this on the board for you, that if you have a base of 3, that the log base 3 will cancel. So in this situation, in order to get rid of that base 5, I create a base of 5. So what that reads is 5 to the log base 5 of x is equal to 5 to the second power. What happens here? And you're left with yes, but what about e? So I'm trying to show you, you're absolutely right. If I were to look at a, I would say it's 25. 5 squared is 25. But when you get to e, that's a little bit more complicated. And so you might want to rethink how you do that. So again, this is the inverse operation piece that we're using. So how do I get rid of the log base 8? I create a base of 8. And so we have 3x minus 7 is equal to 64. 3x is equal to 71. This is 71 thirds. What should you see on your own? You can see the work up there. Check to see if you got it right. Cross off D and F. We go to E. What do we do to both sides? Subtract 6. 2 natural log of x squared minus 2 is equal to 3. Divided by 2 natural log of x squared minus 2 is equal to 3 halves. What to do, what to do, what to do? Create a base of E. I'm left with x squared minus 2. And what is e to the 3 halves power? If you're wondering how to do that on your calculator, again, you locate the e. Oh, second natural log, e to the 3 divided by 2. Make sure you have parentheses around that. 4.48. Add the 2, x squared is 6.48, and then square root. Plus or minus 2.54. There you have it. And I think people generally like this lesson a little bit better than the previous ones. They like solving equations. It's a good time. I like that when we can say, so what did you do today that you enjoyed? I solved logarithmic and exponential functions. Like, no, I had dinner with my kids last time. So what did you do in school today? Oh, then, yeah, you did. What did you learn? I think you already knew everything. No, you didn't. If your parents ask you that tonight, you didn't already know everything. You say, I solved exponential and logarithmic equations. And they'll be like, I'm so proud of you. You're smarter than anybody I've ever met. What? Oh, Cheryl. We'll give a shout out to Cheryl. Cheryl, you were one of our favorite people we've never met in class. And you should ask Kayla what she did in mathematics today. And pretend like you really know what she's talking about and that you are really interested. So, goodbye. All right. So what's different about A, B, C, and D? What's different? Multiple logarithms. So I write them as one logarithm. Log of what? How do I write as one logarithm? Oh, by the way, there should be parentheses around that. Sorry. Write as one logarithm. What do I write? Yeah, division. Very good. X over x plus 1. Now I have it written as one logarithm, so I should get rid of log. How do I get rid of log? Base of 10. So we have x over x plus 1 is equal to 100 over 1. Now what? So 100x plus 100 is equal to 1. Or x, excuse me. Thank you. So I have 99x is equal to negative 100. X is negative 100 over 99. B is almost identical. See if you can do it on your own. I have the work up here. Does anybody have a solution for me? Good. Okay. All right. How is C different? Multiply. So natural log of, what is x plus 2 times x minus 2? X squared minus 4. How do I get rid of the natural log? Base of e. What's e squared? Add the 4. X squared is 11.39. Square both sides. 3 point. Hold on. We got to finish up here. We won't do D. We'll do it at the beginning of class tomorrow, but we got to talk about this real quick and then give you your assignment. There's a problem here, folks. Show me with your hand what the graph of natural log or log looks like. Yeah, it looks like this. So is it safe to say that you can't have a negative number for a logarithm? Can't take the log of a negative number. Well, look, if you type in 3.37, natural log of a positive, natural log of a positive, we're good to go. If you type in negative 3.37, natural log of a negative, natural log of a negative. The negative 3.37 does not work, so therefore we have to exclude it. It's just positive 3.37. So we'll finish up D tomorrow, and what I need you to do, your assignment is right here. I just have these arrows to show you they are just odds for those two sections. So it looks like it's lengthy, but they're odd. So that's every other problem. So it's not that bad. And it is listed on the website as well if you'd rather check that to save time here. So sorry to run over. We had a lot of work to do today. I will give you hopefully a clear schedule of the next 4 or 5 days, maybe even through the semester tomorrow. So see you later.